In the last lecture, we have seen two-state model. So today we will see what is five-state model. Two-state model is good if all the processes are always ready to execute. The queue is a first in, first out list, and processor operates in round-robin fashion on the available processes. Now, what is round-robin fashion? So processor will give time to each and every process, okay, but in circular fashion. So this implementation is inadequate, means the two-state model is inadequate because some processes in the not running state can become ready to execute and others may be blocked waiting for an IO operation to complete. In this situation, the dispatcher have to scan the list, that is the queue, looking for the process that is not blocked and that has been in the queue for the longest time. So to overcome this problem, the not running state is split into two states, that is ready and block state. So in this five-state model, two additional states are added, new and exit. So the five states are running state, ready state, blocked or waiting state, new state and exit state. So which process is in the running state? When we can say that the process is in running state, the process that is currently being executed, okay, we can say that it is in running state, or you can say instructions which are being executed, you can say it's in running state. Next state is ready state. So a process that is prepared to execute when given the opportunity is called in ready state. So the process is waiting to be assigned to a process, to be assigned to the processor, okay. We can say that that process is in a ready state. Next state is blocked or waiting. So a process that cannot execute until some event occurs. For example, the completion of an IO operation can be event. So when the process is waiting for IO operation, we can say that it is in a block state. So the process is waiting for IO operation, completion of waiting for completion of IO operation. Okay. So next state is new state. So a process that has just been created, okay, but has not been admitted to the pool of executable processes by the operating system, okay, it's called a new state. It is called as a we can call that the process is in a new state. So what is the meaning of this? It is created but has not been loaded into main memory, okay, but its process control block has been created. So you can write here the process is being created, is in a new state. Then last is exit. a process that has been released from the pool of executable processes by the operating system. So either because it is halted or because it is aborted for some reason. So we have seen that process termination. So that those processes we can say they are in exit state. So process finished execution, okay, or you can say that halted are said to be in a exit state. So this is a 5-state model. So now we'll see what is processor mode. Processor can be either in user mode or in kernel mode. Whenever user uses any application, he or she is in a user mode. But operating system core functionalities and all the drivers are executed in kernel mode. The processor switches between user and kernel mode. So, for example, in the operating system, any operating system, we want to write uh, a C code or C program using text any editor. So suppose I am using a text editor. So this is what this is an API. Okay, we are using an API to write a C code. Now this program, suppose we have written to read a file and write some data into the file. Now this file is lying where? It is in a hard disk, and hard disk is a hardware, right? So the hardware is controlled by whom? It is controlled by operating system. User cannot access the hardware directly, so he has to go through the operating system. Okay, so to read a file, user has to invoke a system call to access the hardware. So in this situation, the system call will be read, which is shown here. As soon as read system call is given, the system will go in the kernel mode. So for user mode, there is one mode bit which is set to 1, and kernel mode, that mode bit is set to 0. So this mode bit is similar to a flag. Okay, so get system call will generate an interrupt named trap to change the mode from user to kernel. Okay, so for example, if you go to the bank, you are in the user mode and cashier is in a kernel mode. So cashier has the accessibility, or cashier can access the bank details, bank related things, but you are not, you don't have authority to access. Okay, so in kernel mode, the data is read from the file and written into the file using write system call. After reading and writing the system, uh, the system will go to the user mode. So again, okay, what I have shown here is when it was in user mode, the mode bit was 1. So as soon as it is shifted to the kernel mode, the mode bit is set to 0. Similarly, after writing operation, the mode bit will change from 0 to 1. Okay, so okay, so this is how it works. Now, if I tell you that, if I ask you, if I want to add two numbers, okay, you have written a C code, whether it will be in user mode or kernel mode. Okay, so for adding two numbers, we do not need kernel mode, but when we wish to print it on the screen, okay, using printer, then we need a kernel mode. So in the exam, they may ask you to write a short note on processor mode.